Dear students, I am Dr. Tamrakar from Bharati College of Engineering and Technology. I will teach today fluid machinery, some numericals. Today we will learn this question. A jet of water having a velocity of 40 meters per second strike a curved van which is moving with a velocity of 20 meters per second. The jet makes an angle of 30 degrees with the direction of motion of van at inlet and leaves at an angle of 90 degrees to the direction of motion of van at outlet. Draw the velocity triangle at inlet and outlet and determine the van angle at inlet and outlet so that the water enters and leaves the van without shock. Here the data given: velocity of jet, V1 equal to 40 meter per second, velocity of van U1 equal to velocity of van U1 equal to 20 meter per second, angle made by jet at inlet alpha is equal to 30 degree and angle made by leaving jet, that is 90 degree. Leaving jet is given 90 degree. So here we have to draw the inlet and outlet triangles of this question. So we see this is the outlet triangle at 90 degree. It has been given, okay, and this is the van, this is the inlet triangle. Like this. Okay. This is U1. This is point A, B, C, D. This is VW1 overall. VW1 from here to here, and this is U1. U1. This is V1, VF1, VR1 and VF1. This is angle alpha and this one is theta. Now in the outlet triangle, this angle is beta. This angle is phi. No angle here in between, no lines are here. So this is U2, G F E. This is VR1, VR, this is VR2, and V2 equal to VF2, V2 equal to VF2, and this angle is 90 degree. 90 degree. These have been given, and according to this we have to draw the inlet and outlet triangle accordingly. Inlet and outlet triangle, and we have to name according to the question. There are difference in each and every question. तो यहाँ पर एंगल बीटा के लिए बताया हुआ है. दिस एंगल बीटा इज इक्वल टू 180 माइनस 90. ये 90 गिवन है हम लोग का, ठीक है. तो 180 से माइनस करेंगे तो ये हमको यहाँ पर बीटा मिल जाएगा. दिस इज 90 एंड दिस इज बीटा. ये एंगल आपको ये 180 दिया हुआ है. 180 में से ये 90 माइनस करेंगे तो बीटा हमको यहाँ पर 90 डिग्री मिल जा रहा है, ठीक है. तो दिस बीटा एंगल इज 90 डिग्री. ओके. नाउ नेक्स्ट, फॉर दिस प्रॉब्लम इट हैज बीन गिवन दैट U1 इक्वल टू U2 इक्वल टू U इक्वल टू 20 मीटर per second. Now, when angle at inlet and outlet are theta at inlet, when angle and at outlet it is phi. So, from triangle BCD, BCD, tan theta equal to VF1, that is BD by CD, that is VF1 by this CD is VW1 minus U1, VW1 minus U1. Now here we can put the values of VF1 is equal to V1 sin alpha. VF1 is V1 sin alpha, that is equal to 40 sin 30. So this value comes VF1 equal to 20 meter per second, and VW1 equal to V1 cos alpha, while we are making this is V1 sin alpha and this one is V1 cos alpha. By resolving this V1 force, we can get these components. Now this V1 cos alpha, that is equal to, the value of V1 is 40 and this is cos alpha cos 30. That angle is given, alpha is 30. So the value of VW1 comes 20 meter per second VW1, and U1 is given 20 meter per second. U1 is also given, this one is 34.64. This one is 34.64. 34.64 meter per second, and U1 is 20 meter per second. Now putting the values, this tan theta is equal to 20 by 34.64 minus 20. So this comes 1.366. 1.366. So the angle theta is equal to 53.79 degree, or it can also be written as 53 degree 47.4 minute. Now also from angle BCD, here BCD, sin theta equal to VF1 by VR1. This you can see from here, VF1 by VR1. This is sin theta, or VR1 equal to VR1 by changing this. This is VR1 equal to VF1 by sin theta. Now putting the values, VR1 equal to 20 by sin 53.79. So this value of VR1 comes 24.78, and as we know, VR2 equal to VR1, all equal to 24.78, as it has been given in the question that the water enters and leave the van without shock. So VR2 is equal to VR1. Now from triangle EFG, here cos phi is equal to U2 by VR2. Here this is U2 by VR2. So putting the values here, we'll get this is 20 and VR2 is 24.78, 4.78. Then this comes 0.8071. So the value of phi when angle at outlet comes 36.18 degree, or we can say 36 degree and 10.8 minute. So in While solving these type of questions, it is required to make the inlet and outlet triangles. This is very important. Without this, no question can be solved. Thank you. Next, we will take one more example. A jet of water of 50 mm diameter having a velocity of 20 meter per second strikes a curved वेन. एक चीज़ आप ध्यान रखिएगा, सभी क्वेश्चन में ये वेन्स बताता है ना, मोस्ट इम्पॉर्टेंट है, इसको ध्यान रखना. ठीक है, कब कर्व वेन बता रहा है, कब फ्लैट बता रहा है, कब इंक्लाइन बता रहा है, उसके ऊपर से क्वेश्चंस बनेंगे. ठीक है. विच इज मूविंग विथ ए वेलोसिटी ऑफ 10 मीटर पर सेकेंड in the direction of jet. The jet leaves the van at an angle of 60 degree to the direction of motion of the van at outlet. Determine the force exerted by the jet on the van in direction of motion, and second, work done per second by the jet. Now, in this question, it has been given diameter of jet d equal to 50 mm, that is 0.05 meter. So the area A equal to pi by 4 d square, putting the value of t, pi by 4 d 0.05 square. So this is the area of that comes equal to 0.001963 meter square. Velocity of jet V1 is given in the question 20 meter per second, and velocity of van V1, velocity of van U1 is equal to 10 meter per second. It has been given. As the jet and van are moving in the same direction, here the jet and van are moving in the same direction, so alpha equal to 0 as the jet and van moving in same direction, and angle made by jet leaving the jet with the direction of motion is 60 degree. Angle by leaving jet, leaving jet it has been given 60 degree. The angle is 60 degree, so beta is equal to 180 minus 60, so this is 120. But it is clear when the diagram we have to make. This is the outlet triangle. Here this is the outlet triangle, and this is the vein, and this is the inlet. So in inlet there is no triangle because alpha is 0, so all angles are in this line, and every factors are here. This one is U1, this overall V1 equal to VW1, this is the overall V1 equal to VW1, this is the U1 here, and this is VR1. Everything is in the straight line. This is A, C and B. Okay, and at the outlet this is given VF1, VF2, V2 and VR2. This is V2 and VR2, F, G, H. This is E, and this angle is given 60 degree. Okay. So in the outlet triangle, this is VW2, this is U2. Here the factors are different according to the question, and this is angle phi, this is angle 60, this is 60, so this is also 60, and this is angle beta. V2 makes with this horizontal is the angle beta. Okay. Here in this problem U1 equal to U2 equal to U equal to 10 meter per second for the shock, without shock, this question. Okay, so in this question we have to calculate the VR1. So here VR1 is equal to VW1 minus U1, that is AC